Now let's implement same logic in a C program. Start a new project. Include headers. Declare integer variables. Here, variable numRow will store number of rows in first mat. NumCol will store number of columns in first mat. Similarly, numRow2 and numCol2 will store number of rows and columns in second mat. Also, integer variable matRow will be used to store matrix row index. Here, variable matCol will be used to store matrix column index. Next, declare integer variable I. Also declare and initialize variable sum with value 0. Next, declare 3 two-dimensional arrays with size 2. Here, array first mat will hold first matrix values. Array second mat will store values in second mat. Also, result will be available in matrix result mat. Next, ask user to enter number of rows and columns in first matrix and thereby store them in variables. Here we have variables numRow and numCol to store row and column count. Next, ask user to enter elements in first matrix. Let's assume user inputs values, as we have discussed in our part 1 unit. In any array, index will be starting from value 0. The first location to store any value in first mat would be first mat of 0, 0. Also, second element in first mat array will be available in index first mat of 0, 1. Third value will be stored at array index 1, 0. And fourth element at array index 1, 1. If you notice carefully, first value gets stored in index 0, 0. Second element at index 0, 1. Here, column value is incrementing by 1. Next, start a for loop. Initialize value of column index as 0. Provide for loop condition expression as mat column less than total number of columns in first mat. Now, program will enter for loop. Here we have condition true. That is matCol is less than total column count of 2. First matrix element will be stored at location first mat of 0, 0. Here, we have value for column as 0, but row index is missing. To use row index, include a for loop before our current for loop. New for loop will have matRow initialized as 0 with condition expression as matRow less than number of rows in first mat. Also increment matRow. Now, get first matrix element using scanf function. Next, matCol value will be incremented by 1. Here, condition matCol less than numCol is true. Scanf will execute second time. Thus, second matrix element gets saved at first mat of 0, 1. Now, third time when for loop executes, value at matCol is 2. But condition results false, as matCol is not less than numCol. Now, program will move to parent for loop. Value of matRow will be incremented by 1. Now matRow is 1. Condition matRow less than numRow stands true. Program enters child for loop. Here, matCol is initialized 0, condition is checked. Scanf will be executed, and third matrix element will be saved at first mat array of 1 0. Next, value of mat col is incremented by 1. Also, condition mat col is less than 2. Scanf function is executed. Thus we have fourth element stored at first mat of 1 1. Now, we have saved values of our first matrix to array first mat. Now, perform the same operation to store elements in our second matrix. Here just copy source code that we have used to store elements in our first mat. Here replace variables numRow and numCol with numRow2 and numCol2 respectively. Now, we have two matrices ready. We have already learned pattern to find multiplication result. Place our formula to find result. Now get value at first mat 0 0. Multiply it with second mat 0 0. To get values as above, place a for loop. Initialize variable I with 0. Let loop iterate till I less than numRow2. Here, variable I will be used as column index of first mat, and also, same value will be used as row index of second mat. Next, place a for loop just above the current loop. Initialize mat row equals 0. Let the loop flow till mat row value is less than numRow. We now have row index value for first mat. Here, we need index for column value in array second mat. Hence place a for loop and initialize value of mat col is 0. Let loop execute till mat col less than numCol2. Our program will now multiply elements of each row of the first matrix by the elements of each column in the second matrix and add their products. Each added result will be stored in another matrix. We have array result mat to save result. Next, let's display the result from array result mat. As we have a two-dimensional array, place two for loops. One with a condition mat row variable less than number of rows in first mat, and another for loop with condition variable mat col less than number of columns in second mat. Print values available in array result mat. Thus we have completed matrix multiplication. Now, save program and run. Give input array values and cross-check results. Hope you understood the logic behind matrix multiplication. I have not added any validation to check number of row in first mat equals to number of rows in second matrix. You can include in your program while practicing. Thank you for patiently taking this unit.